The United States military is rapidly approaching the most critical milestone in the history of the F-35 program. By the middle of this year, Pratt Whitney is scheduled to face the critical design review for the engine core upgrade, the multi-billion-dollar fix designed to save the F-35 from literally overheating itself to death. This is an engineering Hail Mary that will dictate the combat effectiveness of the F-35 fleet for the next 30 years. Block 4 is the most aggressive, ambitious modernization program in the history of the F-35. It is essentially an entire brain transplant for the jet. It includes a brand new AESA radar, a next-generation electronic warfare, the integration of new long-range precision weapons, and massive upgrades to multi-domain data links. Block 4 fundamentally elevates the F-35 from a standard 5th-generation fighter to a quasi-6th-generation asset. But more computing power equals more heat. When Lockheed Martin originally designed the F-35's thermal management system, they built it with a cooling capacity of roughly 32 kilowatts. That was plenty for the original specs. But when the Pentagon finalized the requirements for Block 4, they realized the new radar and jammers were going to require between 62 and 80 kilowatts of cooling power. That is more than double the original design limit. To keep the jet from melting down, the F-35's current F-135 engine is being forced to work in overdrive. It is constantly being run above its intended design parameters, just to push enough cooling air into the jet's thermal management system. When you run a jet engine past the red line every single day, you destroy it. The critical hot sections of the engine, the parts that endure the highest temperatures, were designed to last for 2,000 flight hours before requiring a major overhaul. Because they are working so hard to cool the jet, that lifespan has plummeted to just 1,600 hours. This translates to more frequent engine teardowns, more grounded aircraft, and a staggering financial penalty. The Pentagon calculated that if they do nothing, this overheating issue alone will add an additional $38 billion in lifecycle maintenance costs. For $38 billion, you could just buy hundreds of brand new F-35s. The Pentagon realized they had to stop the bleeding. They needed to upgrade the engine. When the Pentagon asked the defense industry for a solution, two radically different paths emerged. The first option was the General Electric XA100. This was a completely new, revolutionary piece of technology, known as an adaptive cycle engine. For the last 50 years, jet engine designers have faced a brutal compromise. You can build a narrow, low-bypass engine for massive thrust and supersonic speed, like in a fighter jet. Or you can build a wide, high-bypass engine for fuel efficiency and range, like on a commercial airliner. You couldn't have both. The adaptive cycle engine breaks that rule. The XA100 utilizes a third stream of airflow, a third duct that wraps around the core of the engine. During high-speed dogfights or supersonic dashes, the engine closes the third stream, acting like a traditional fighter jet engine to generate maximum thrust. But during long-range cruise profiles, the engine opens the third stream, increasing bypass air and dramatically improving fuel efficiency. Furthermore, this massive third stream of air acts as an incredible natural heat sink, vastly improving cooling capacity. The numbers on the XA100 were staggering. Compared to the current F-135 engine, the GE XA100 offered a 25% increase in fuel efficiency, a 30% increase in combat range, a 20% increase in acceleration, and it completely doubled the thermal management capacity. For the US Air Force, which operates the conventional F-35A, this was a dream come true. A 30% range increase is vital for the massive distances required in a potential Pacific conflict, but there was a fatal flaw in the XA100 plan. It didn't fit the Marine Corps' F-35B. The F-35B is the short takeoff and vertical landing variant. It relies on a massive lift fan positioned right behind the cockpit, driven by a complex drive shaft connected to the engine. The revolutionary three-stream architecture of the XA100 was mechanically incompatible with this vertical lift system. If the Pentagon chose the XA100, the Air Force would get a phenomenal new engine, but the Navy and Marines would be stuck with the old one. Furthermore, the Air Force estimated it would cost over $6 billion just to finish the engineering and integration for the F-35A alone. The Navy and Marines refused to pay for an engine they couldn't use, leaving the Air Force to foot the entire bill. It was simply too expensive and too disjointed. The Pentagon killed the XA-100 for the F-35. The Pentagon chose the second option, Pratt & Whitney's engine core upgrade. Pratt & Whitney's pitch was highly pragmatic. They argued, "We have already built a massive global supply chain and maintenance network for the F-135 engine. Why throw it all away? Let's just surgically upgrade the core of the existing engine." The ECU is a massive overhaul of the engine's power-generating heart. While the exact details are highly classified, the upgrade requires a complete redesign of the high-pressure compressor, the combustor, and the high-pressure turbine. Pratt & Whitney promises that the ECU will deliver a 10% increase in thrust, a 10% increase in range, and most importantly, a 50% increase in thermal management capacity. While those numbers aren't as sexy as GE's adaptive engine, the ECU has one massive, unbeatable advantage. It is entirely plug and play. The ECU does not change the exterior dimensions of the engine, nor does it alter the physical interfaces with the airframe. It can be installed seamlessly into brand new jets rolling off the assembly line, and older F-35s can be retrofitted during routine maintenance at depots all over the globe. Most importantly, the exact same ECU upgrade works for the F-35A, the Marine Corps' F-35B, and the Navy's F-35C. One solution fits the entire fleet. And the price tag? The development cost for the ECU is estimated at roughly $2 billion, a massive savings compared to the XA-100. So, the Pentagon made its choice. But choosing a plan and actually executing it are two very different things. In 2024, Pratt & Whitney successfully passed the preliminary design review, but the true test is happening right now, in mid-2026, the critical design review. Originally, the CDR was scheduled for 2025. It was pushed to the middle of 2026. Pratt & Whitney hasn't officially stated why, but defense analysts know exactly what is happening. The engineering is brutally difficult. A critical design review is not a PowerPoint presentation. It is the moment where the engineers have to prove, with hard math, exactly what materials they are using, how the turbine blades will survive unprecedented temperatures, and how the cooling air will be routed. They have to increase thrust by 10% and cooling by 50% without making the engine a single millimeter larger. It is an engineering nightmare. To pull this off, Pratt & Whitney is relying heavily on next-generation materials like ceramic matrix composites, which allow turbine blades to operate at temperatures that would melt traditional metals. They are also utilizing advanced 3D printing to consolidate dozens of individual parts into single, stronger, lighter components. But Pratt & Whitney is only fighting half the battle. Even if the ECU engine provides 80 kilowatts of cooling air, it is useless unless the jet's internal plumbing can actually distribute it. This system is called the Power and Thermal Management System. Right now, defense contractors Honeywell and RTX's Collins Aerospace are locked in a fierce bidding war to build the upgraded PTMS for the F-35. Collins claims their new EPAC system can already handle the 80 kilowatt load, while Honeywell promises a 25% boost to the existing system. The winner of this contract won't be selected until late 2026. This means Pratt & Whitney has to finalize the design of their engine before they know exactly what cooling system it will be plugged into. They have to design the ECU with enough mechanical flexibility to handle either PTMS option. That is almost certainly why the critical design review was pushed to 2026. If Pratt & Whitney passes the CDR this summer, they face an even bigger hurdle: mass production. Over the last 5 years, Pratt & Whitney has invested over $1 billion to modernize their facilities and increase F-135 production by 20%. But the strain is showing. In 2024, the delivery of 123 F-135 engines was delayed by an average of 155 days. Injecting a massive, highly complex core upgrade into a production line that is already running red hot is a massive logistical risk. But the Pentagon is not backing down. They are flooding Pratt & Whitney with cash to ensure this happens. In late March 2026, the DoD awarded Pratt & Whitney a staggering $6.6 billion contract for lots 18 and 19 of the F-135 engine. In March and April, the Pentagon dumped another $600 million specifically for the advanced procurement of long lead materials explicitly tied to the ECU project. They are putting 500 dedicated engineers into a fully digital engineering environment to run millions of thermodynamic simulations. The money is there, the political will is there, the 2029 delivery deadline is locked in. But what about the General Electric XA100? Did the Pentagon just burn billions of dollars developing a revolutionary adaptive cycle engine, only to throw it in the trash? Absolutely not. The US military does not waste good engineering. When the Pentagon decided the F-35 would use the ECU, they took the adaptive cycle technology and pushed it into a much higher, much more classified weight class, the Next Generation Adaptive Propulsion Program. The NGAP program is the beating heart of the Air Force's upcoming 6th-generation fighter, the F-47. The United States looked at the XA-100 and realized this tech is incredible, but it doesn't belong in a 5th-gen strike fighter. It belongs in a 6th-gen air dominance platform. The goal of NGAP is to provide the 6th-generation fighter with a 30% range increase over the F-22 Raptor, while offering massive thermal capacity to cool the directed energy weapons and advanced jammers of the 2030s. General Electric has evolved the XA-100 into the XA-100 II. Pratt & Whitney, not to be left out, evolved their own adaptive prototype into the XA-103,000. And as of mid-May 2026, the NGAP program hit a massive inflection point. Both Pratt & Whitney and General Electric officially announced that their XA-103,000 and XA-102 designs have passed the assembly readiness review. This means the digital design phase is over. The blueprints are locked. They are actively coordinating with suppliers to bend metal and build the physical prototypes, with the next contract evaluation phase set for late 2026. Now, building the most advanced jet engine in human history takes time. The Air Force recently admitted in its 2027 budget documents that the NGAP engine program has been delayed by roughly 3 years, with full deployment not expected until 2031. Because Boeing's F-47 fighter is expected to make its first flight around 2028, those initial prototypes will likely fly using transitional engines, potentially modified F-119s or F-135s, until the NGAP engines are ready for installation. But in the world of 6th-generation aerospace, a 3-year delay is standard operating procedure. The physics are simply too complex to rush. When you look at the macro picture in May 2026, the United States strategy is brilliantly clear. It is a dual-track approach. They are executing pragmatic, highly targeted surgery on the F-35 via the ECU, ensuring that their massive fleet of 5th-generation fighters can utilize the devastating capabilities of Block 4 without melting down. It is the cost-effective, realistic solution to secure the present. Simultaneously, they are taking the most exotic, revolutionary engine technology on the planet, the adaptive cycle, and reserving it specifically to ensure their 6th-generation fighter is absolutely untouchable when it debuts in the next decade. The critical design review for the F-35's engine core upgrade this summer is the ultimate crucible. If Pratt & Whitney passes, the F-35 secures its dominance for the next 30 years. If they stumble, the $38 billion maintenance bill comes due.